Students, we are still continuing with exercise 1E, and this time in this video we're going to see how to solve question number 3. So let us see question number 3 from exercise 1E. Question number 3 states that without actually performing the long division, means what? Without actually performing the division, okay? Long division, without actually performing the divide, state or say whether the following rational numbers, these are three rational numbers given to you, whether the following rational numbers will have terminating decimal expansion, or a non-terminating decimal expansion. As you all know from the previous videos or from the previous classes, that any rational number, these are all rational number of the form p by q, okay? Any rational number can have either terminating decimal expansion or non-terminating but repeating decimal expansion. So now you have to identify which of these have decimal form such that which stops, terminates, or which doesn't terminate but repeat, okay? So one method is very simple, is what you divide in the rough, or you divide yourself, and you see the answer. If the division part stops, it is terminating. If the division part continues and doesn't stop, the division doesn't stop, the division become long but it will not end, then that is non-terminating and repeating. And most important, like a particular digit or a particular group of digits will repeat, so that's non-terminating repeating. But for that you have to divide. But in this question number 3, they have clearly stated that you are not to perform long division, you are not allowed to divide, okay? Without dividing, without actually performing the divide, you have to say whether these numbers have, rational numbers have, terminating decimal expansion or non-terminating but repeating decimal expansion. So how to do? Then here's the answer. If you want to find out whether a given rational number has terminating or non-terminating repeating decimal without dividing, without doing the divide, or without using calculator, the best way is what, I told you that first of all, the first step is what? Check whether the given number is in simplest form or not, simplest form or lowest form. If something can cancel not, okay, like in question number 2, we cancel and then become, okay, the solution was done, okay? So first of all, you have to find out that whether the given rational number is in simplest form or not, okay? And how does the simplest form? Simplest form means when the numerator and denominator are co-prime, means what? They are safe as 1. You cannot divide anymore this numerator and denominator by same table, okay, or by same multiple, okay? So first of all, make sure that the given number is in the lowest form. Then after that, you do the prime factorization of the denominator in all the sums, okay, not in 3, 4 also. In all the sums, whenever you have to find a rational number is given and you have to find terminating and non-terminating repeating decimal, this is the principle, okay, this is the procedure, okay, clear? You have to first change the given number in the simplest form by cancelling, if it's possible, to its simplest form, and then after that you do prime factorization of only the denominator. Keep in mind, only the denominator. See here in question number 3, it's already done prime factorization because 2, 5 and 7 are prime number and already in power form, okay? So this is already done for you. Same way you have to do for number 1 and number 2 also, okay? You do only the prime factorization of the denominator, and then after doing prime factorization of denominator, let us say that this a by b, a by b, a by b, then that b, you have to do prime factorization of b. You know the rule that if your denominator b is the denominator here, if your denominator b is in this form, it comes in this form, means they are prime factors of 2 and 5 only with some power which are non-negative, okay? Then this will have terminating decimal expansion, okay? If b is in this form, if denominator in this form, strictly in this form, then it will have terminating decimal expansion. And if your denominator b is not in this form, it's not in this form, you cannot convert b in this form, then it will have non-terminating and repeating decimal expansion, okay, clear? It will have non-terminating and repeating decimal expansion. So means what? You just have to now do the same way which I have explained just now. So let's start with question number 1, okay? So the first number here, the first rational number given here is what? 125 divided by 44, okay? So what it is that first we'll check whether we can divide or not, we can cancel or not, okay? Sometimes it's difficult to find out whether we can cancel or not by same table. So one of the best way to find out is what, you just do the prime factorization of up and down, okay, to see whether we can cancel or not, okay? See, 5 is odd number, we can divide by 2, okay, prime factorization, and then remember prime numbers, 2, 3, 5, 7, 9. So if you cannot divide by 2, then try by 3. For 3, remember, we have to add 5, 6, 7, 8. 8 doesn't come in the table of 3. That means we cannot divide by 3 also. 2, 3, 5. Next one, 5. And yes, we can divide by 5 because you know this is 5. Okay, you can divide by 5, you have to 0 5. So it's 5, you can divide by 5. 5 2s are 10, 5 is 25. 25 is a multiple of 5, 5 is 25, and 5 1s are 5. Okay, so we have done prime fraction of 125. Actually, I'm not solving the answer. I'm just checking. I'm just trying to find out whether we can cancel or not, whether this given number is already in simplest form or we have to make it to simplest form. Okay, convert to simplest form. So for that, the best way is what you can just do prime factorization like this, and you can do prime fraction of this also. Even number 4, we can divide by 2 to the 4 to the 4. Again, even number 2 1s are 2, 2 1s are 2, and you know 11. 11 is a prime number. Prime number, the moment you see divide by it's 11 1s are 11. Now see the prime factorization. 125 we got 5 into 5 into 5. No need to write in power, just to see, we want to just to see like whether you can divide or not. And 44 is got 2 into 2 into 11. Now see, is there any common prime factor? Common, like 5 is here, is there any 5? No. 2 is here, is there any 2? No. Is 11 is here? No. Since there's nothing common, means what? We cannot cancel these two numbers by same table. Suppose that there's 5 here, and in 44 also 5 is coming here. That means we can cancel by 5. Okay, obviously in upper number there's 2 here, but no numbers 2, then you can cancel by 2. Okay, or if 2 to 2 times, 2 times, then 2 into 4, 2 into 4, then you cancel by 4. Okay, means what? The common prime factors, if they are there, by that table you can cancel up and down. Okay, so here we confirm that we are now it's sure that we cannot cancel anymore because the HCF is 1. HCF is 1, highest common factor is 1, because nothing is common, so this 1 is common. Okay, clear. HCF is 1. So means what? We cannot cancel anymore. So it's already in the lowest form. I told you that first you make sure that it is in the lowest form. That is in the lowest form. Now confirm. After the second part is what? Now you just find the prime factorization of only the denominator 44. Okay, but while checking here, we have already done the prime factorization of denominator. See, 44 we have already done. The 44 what you got? 44 we got 2 into 2 into 11. 2 into 2 into 11. Okay, now we'll write in power notation. 125 by 2 into 2, we write 2 square, and 11 is a prime factor, so only one time 1. Now you look at the denominator 2 square into 11 to the power 1 and compare this power with the condition that is required for number to become terminating and non-terminating. Remember the condition? For any rational number a by b, if a by b is a rational number, b should be in this one of this form. Okay, if this denominator is strictly in this form, then it will have terminating, but the form should be what? There should be 2 and 5, and there should be no other prime number. There should be 2 and 5, there should be no other prime number. But see, look, 2 is there, but 5 is not here, and moreover 11 is there. 11 is another prime number. That means what? If you look at this denominator, clearly that this denominator is not equal to in this form. Look, the denominator b in for this given rational number, we can see that the denominator b is not in this form. It is not in this form. So right here, since the denominator clearly mentions denominator, since the denominator, what is the denominator here? 2 square into 11 to the power 1 is not in the form of what? 2 to the power m into 5 to the power n. See, it's not in this form. It is not in this form where, no, we need 2 matching, but 11 and 5 not matching. So it means it's not in this form. Since the denominator, this denominator is not exactly this form, but you always mention the meaning of m and n, where m and n are non-negative integers. So we know the condition that when the denominator b is not in this form, then it will have non-terminating and repeating decimal expansion. No, so hence we can say what? Because the denominator is not in this form, it is not in this form, therefore this given rational number, because this came from here, 125 by 144, hence the given rational number, what rational number? The given rational number 125 by 44. This given rational number has, tell me which kind of decimal form now? Since b is not in this form, this denominator b is not in this form, therefore it will have non-terminating repeating decimal expansion. So therefore the given rational number has a non-terminating and non-terminating repeating decimal expansion. Okay, so it will have non-terminating and repeating decimal expansion. Okay, instead of it, so this is the way of doing. Okay, this sum. Now let me show you question number 2, solution to sub number 2 from this question. Okay, so number 2 is given here 23/8. Okay, so we start first. So first of all we have to check again whether this given rational number is already in the whether this given rational number is already in the simplest form or not. Okay, clear? So to check whether this given rational number is in simplest format, we'll do the same thing. We'll think like whether we can divide by same table or not. Okay, so for that, best way is what? Do the prime factorization. 23. Now if you see 23 we can divide by what? Nothing like that, because should we divide by 2, should we divide by 3? Prime numbers, no? Prime factorization. So if you remember the list of prime numbers, you know that 23 is a prime number. 23 is a prime. So students, there's a prime number, and if you look very carefully, 23 is itself a prime number. So whenever you see any prime number, no need to waste time. Prime numbers are divisible by itself only. So that means to divide 23, to find the prime factor of 23, I should divide by itself. 23 1 23. And for 8, 2 4 is 8, even number, 2 2 is 4. So you can find that there's no common prime factor. 23 here, 23 not, 2 here, and 2 not here. Okay. So since there's no common prime factor, that means what? We cannot cancel anymore. Okay. That means this is already in the simplest form. Okay. This given number is already in simplest form. After you make sure that it's simplest form, now we'll do prime factorization of the denominator. Okay, of 8. Okay, clear? So let's do prime factorization of 8, and prime factorization of 8, you know what you got? 2 into 2 into 2. Just now I showed you what is the prime factorization of 8. It's 2 into 2 into 2. Okay, so this one. Now we'll write in power notation. 2 how many times? 1 to 3. So write 2 one time and power 3. So we got the power notation of denominator. Okay, a by b, but you have to do the prime factorization of b. But as I told you that any rational number will have terminating decimal function if b is in this form, and any rational number will have non-terminating if b is not in this form. So if you look at these two and look at the present denominator b, you'll think that since it's not in this form, it's not in this form because there's only 2 here. See, 2 we got in prime factorization, but there's no 5, and see we need 5 here. Then you may think that no, you may be in hurry to conclude that it will have non-terminating and repeating because it is not in this form. But no, as I said, that for this form to happen, 2 and 5 we need prime factor, yes, but powers can be non-negative. Means powers should be what? Non-negative. These are all integers. And here m and n carry non-negative. Means what? These are all excluded. Means the m and n can have these powers. Means 0 power is also allowed. Okay, so that's why, since power 0 is allowed, so I'll see I can bring here 5 with power 0. See how? Look, and then I can change in this form. Okay, clear? So do not be in a hurry to conclude. Okay, directly whether I have terminating, non-terminating. So it's having only 2 and no 5 doesn't mean that it will have non-terminating. Okay, so that's what I do is that we'll change this in that form. Okay, we'll try to change in this form. Okay, clear? So what I'll do, this 23, now in this 2 to the power 3 we multiply from here 1, because you know that when you multiply 1 to any number, the result is same, like 1 into 5 5, 10 into 1, 10. 8 into 1, 8. 7 into 1, 7. 100 into 1, 100. Multiplying 1 to any number doesn't change the result, okay? Clear? This is called multiplicative identity, okay? 1 is the multiplicative of all the integers, okay? When you multiply 1 to any number, the result doesn't change. It will come same. That's why when you multiply 1 to 2 cube also, it will come 2 cube only, okay? 2 cube means 8, and 8 into 1, 8. It will come back 8. But now, what I'll do is that 2 cube same. In place of 1, we can write here 5 raised to power 0, because see, I need to make in this form. Any rational number, if the denominator is in this form, will have terminating. And since power 0 is allowed, that's why I say I remove 1, and in place of 1 I write here 5 to power 0. But the reason, but you should question me, or question yourself also, if you want to understand, if you are very eager to know that how come 1 has been replaced by 5 to power 0. Then the answer is here, because we know the rule that any number, not only 5, any number 1, 2, 3, 4, 5, 6, any number, any integer, any rational number whose power is 0, its value is 1. Keep in mind that any number having power 0, its value is always equal to 1, okay? Maybe this I can show you in some other video, okay? I'll show you in some other video like why any number raised to power 0, its value is 1, okay? But at present, you just remember that if a is any rational number, then this a raised to power 0 has a value equal to 1. Keep in mind. So since they're equal, in place of this I can write 1, and in place of 1 also I can write 8 power 0, because they're equal. The values are equal, okay? Equal. So that means what? In place of 1 I can write 5 raised to power 0. In place of 1 I can remove 1, and in place of this one, when I remove 1, there will be empty space, and in that empty space I can put here 5 to power 0, because they are equal. In place of 1 I can write 5 raised to power 0, because 5 raised to power 0 also means 1, okay? 5 raised to power 0 also means 1, and 2 cube means 8, and 8 into 1 will come back 8, okay? But now it is 5 raised to power 0, okay? So means you should do like this, okay? Clear? Now look at the denominator. Now we have denominator having 2 and 5 prime factor, because 2 and 5 are prime factor, with power 3 and 0. Now is it matching with this form? Yes, because see, I told you that if a by b is a rational number, you have to prime factorize b. And if b comes in this form, where m and n are non-negative integer, means what? M can take any value from 0 to positive values of this integer, and n also can take 0 or more than 0, okay? Any value. N also can take value 0 or more than 0. I'm clearly mentioned. That's why 0 is also allowed. So here 0. Okay. So say it's coming in this form. So right here. So right here. Since the denominator clearly mentioned the denominator here, like this, how we have done question 1 of this sum. Since the denominator clearly mentioned denominator, 2 cube into 5 power 0 is of the form. What form? Is of the form 2 to the power m into 5 to the power n. Look, see, it is matching this form, where m and n are non-negative, integers. See, this generator 2 cube into 5 power 0 is of the form, it's exactly matching this form. Say 2 and 2, 5 and 5. M is power 3, which is positive, non-negative, and n is also 0, means non-negative, because not minus, and 0 has no sign, okay? So it's matching. So since I told you, since any number whose denominator is in this form, then it will have terminating decimal expansion. Means what? If you divide in the rough also, you'll get exactly that. It will be terminating decimal expansion, okay? So therefore, we can conclude that therefore the given rational number, which rational number? The number which is in the question. The given rational number 23 by 8 has what? Has a terminating, because if the denominator is in this form, it will have It will always have terminating decimal expansion. Okay, so we conclude it will have terminating decimal expansion. Okay, so students, in these two sums we have seen that the question number 1 has non-terminating and repeating decimal, and question number 2 has terminating decimal expansion. We have concluded, but did we divide? We did not divide so far. We have said these two answers, see, without actually doing the divide. Okay, but just for your understanding, let us divide these two sums and see the answer. That does the actual answer matches with this theoretical answer or not? Like, if I divide, suppose these two, and we'll get same answer like this. Suppose if I divide 125 by 44, we will still get non-terminating and repeating, and if I divide 23 by 8, we'll get terminating. Okay, so to see this, let me divide and show you the answer. Okay, so let me divide and show you the. So students, I've done the division here. You can see 125 divided by 44. See, it's a long division. This time I've done. Okay, just to check my answer. Okay, the question telling us without dividing, okay, without actually performing divide, you say whether these numbers have terminating or non-terminating repeating. So as you know, in number 1 we have found that without dividing also we have found that it is non-terminating and it has repeating decimal expansion. Okay, because the denominator is not in this form. And here also say, look, if I divide 125 by 44 actually and do long division, look, I get 2.84, then 09, 09, 09, 09, and she'll keep on going, it will not stop. So which I write, if I write in this way, I can say that 2.84, up to here no repetition. Then 09 is repeating, so I can write 09 bar. That means what? 09 is repeating. So yes, it's a non-terminating and repeating decimal expansion, which is matching to the result, okay, of number 1, okay, because the reference form. Okay, so here also we got non-terminating and repeating, and here also we're getting, by dividing also we're getting non-terminating and repeating. Okay, 09, 09, 09 is repeating. Okay, and see number 2, we have found that without dividing, when we do the prime factorization of denominator, the denominator is in this form. Yes, see, it's matching in this form. It's matching in this form. And if the denominator is in this form, it will have terminating decimal expansion. Terminating, it will stop. So we conclude here the given rational number has terminating. Okay, in number 2. But here without dividing. But if I divide actually 23 by 8 also, look, you can see I've shown here. If I divide 23 by 8, you'll find that the division stops. Because the remainder 0 means the division terminates. And see, it is a terminating decimal 2.875. After decimal, there are only 3 digits and stops. So it's terminating decimal expansion. So means our answer matching with the practical result. Okay, by dividing also it's matching with the theoretical result. Okay, without dividing. Okay, so I hope you have understood. So number 3 also will do same way, so you can try by yourself number 3. Okay, from this question number 3. Okay, same thing you do the prime factorization of numerator. First you see whether it's in lowest form or not, whether you can cancel something or not. If you can cancel, then do the prime factorization of denominator, and say the prime factorization of denominator is already done for you. Only you have to confirm that whether you can cancel or not. Okay, anything. Then after that, see the denominator. If the denominator is in this form, it will have terminating, and if the denominator is not in this form, it is non-terminating and repeating. Okay, so number 3 you all try by yourself. Okay, thank you.